Hello and welcome to Tiny Code Christmas Day 6, and today we're going to be taking a look at a classic sign scroller effect. Before we go any further though, I just want to ask you to please share your work on social media so that it can be included in our upcoming showcase. So there's links below in the description to the Lovebyte Discord, the Lovebyte Mastodon and the Lovebyte X page. Please follow us and share your work with the hashtag LovebyteTCC. This is a sign scroller. We're going to take a look at it in an overview first, and then we'll split off into TIC80 and Pico8. So, as we saw on the title screen there, we are going to make a sign scroller, and if we just take a quick look again at our sign visualizer, it's this up and down motion here that we want to apply individually to each letter, so that each letter has a different position as a result of the sign value being applied to it, and then on top of that we just move the text to the left. Nothing special there. So we are going to take a look at the TIC80 first, and then we'll take a look at the Pico8. So I've defined some text up at the top here, and I have t equal to 0, which we're going to use to keep track of our time. So the first thing that we need to do is we need to print this out to the screen. Now we haven't really taken a look at the print function, so let's go to help, print. And if we take a look here, the print function on the TIC80 takes the text first, then the X and Y coordinate, then a color, and then whether we want it to be fixed width set to true or false, and we will want that because if we're going to be printing each letter individually, we don't want to have to figure out the spacing for each one. Then we have the scale, whether we want it to be the original default text size or whether we wanted multiples of it. And then we also have the option of a small font, which is not something that we're going to take a look at. And then that returns to us the width of the text that we've actually printed. So we won't be using that, but we will be taking a look at the text, XY coordinate, color, fixed width, and the scale. So I'm going to print this out. First thing I'm going to print out is the text, then the X and Y coordinate, and then the color. So I'll just give it 12 as the color. Then whether we want it fixed, true or false. So I'm going to set that to false first so that we can take a look at it, and then I'll change it to true. And then the last thing is the scale. So I will leave that at 1 for now. And these options are all everything except the text is optional, so small font will default to false and there's no need for us to specify it. So now we have Tiny Code Christmas printed in the top left hand corner, and if we just take a look here, you'll notice that the spacing between them is all nice and even. And if we come back and change this to fixed width, you'll see that there's slightly different gaps because each letter is the same width, even if that letter, like the I here, is shorter and the I here. So you can see that there's a few letters that create gaps in the exclamation mark when we use fixed width, but we're going to have to deal with that because otherwise we would have to measure each letter and adjust it. So that's something you can take on if you want, but not something that I'm going to be recommending or doing. So first thing that we'll do is we're going to move our text into the center of the screen. So on the y-axis here, I'm just going to change this roughly to 68 and give or take a few of the pixels of the font. That'll do us for roughly being the center. And I am going to leave it where it is on the X coordinate for now. And the next thing that we need to take a look at is how do we print this out letter by letter. So as you saw in the preview, the sign scroller assigns an individual height to each letter in the string. Now with this text, it might be tempting to think that we could index it as if it was a table or an array, but unfortunately that is not the case. So I'm going to set up a for loop, and we're going to loop from 1 to the count of text, and that's what that hash sign before text means. Start at 1 and go to the number of letters in that string, and that works for any type of table as well. So now we have to take a look at how we can print the individual letter. So it might be tempting to think that we can index it as an array, and unfortunately that will just give us nil. So instead what we have to do is we have to use the Lua string.sub function, and we have to pass it in the text, and then we have to specify a range. So this is a substring function, so I'm saying I want to retrieve a substring from text, meaning a smaller part of it, and I can do that by specifying the start and the end. So I'm going to make them both I in this case, because if we take a look here, we're starting at I and we're looping up from 1 to the number of text here. So if I want to get a substring, I want the substring that starts at 1 and ends at 1, starts at 2, ends at 2, starts at 3, ends at 3, and so on. So I'm just going to run this, and you can see it's printed every single letter on top of each other in the one space here. So I've told it to print each letter, iterate through the for loop, print one letter at a time, but print them all here over at 0.68. So what I'm going to do instead is I'm going to maybe take the position I that the letter is, and I'm going to maybe multiply that by 10. Okay, not too bad, and I'll maybe change that to 6, and now we have Tiny Code Christmas printing out. But we're not just printing it out normally, we're printing it out letter by letter. So before we go any further, I'm going to change the scale of this. So I'm going to change it to be maybe 3, which makes the letters all big again, and I have to space them out a bit more. That looks about right. So we're taking the position of the letter, using that as the x coordinate, but multiplying it by 18. So that'll be 1 times 18, 2 times 18. So the first letter will be at 18 pixels in from the left, then 36, and so I'm actually want to start a little bit of animation on this so far, and I'm just adding 1 to t, so every time the function gets called, t will increment by 1, and I'm going to subtract that from the x coordinate, which will result in our text scrolling. And if I want, I can add 240 to this so that the text starts from over here off the side of the screen. Now, just for the sake of quickly seeing the text, I'm going to leave that off for now, but it's something that you can add in if you want the scroller to start off of the screen. And I'm just going to adjust that height again, just so that it looks like it's in the center. And now what I need to do is adjust the height of each individual letter. So I'm in a for loop that is visiting each individual letter, and I want to apply a sign value to the height of that. X is the horizontal value, 60 here is the current Y value. So what I just need to do is I need to put in a mat.sign, and I'll use I, so I'll use the current position in the string, and I'm going to see if that does anything visible. So you can see there's a slight variation by a pixel or two, but if I multiply it by 10, now you'll see that it actually has applied that sign individually to each one of those letters. So when we're talking about animating this particular effect, it is this term that we're going to need to animate, to add a time value to in some way. So I'll leave that for you to figure out as part of the challenge. So we are at 169 characters. The limit today is 256 characters for this challenge, but I want you to combine this with another effect. As you saw, for example, I put it in front of the tunnel effect. I added some extra text effect by printing the text multiple times with a slight offset, and you might want to actually make this text a bit longer. Why don't you, maybe in the time-honored Demoscene tradition, why don't you greet some of your fellow TCC participants? So that's it for today. Best of luck. So to start off, I've defined text up here with the value tinycode Christmas, and we are going to print out that text. So I'm going to use the print function, and I'm going to type help print and see what this tells us about it. So some interesting stuff here. Print the string at XY, or the current cursor position, and it takes string, XY and color. And we can see that there's also some extra bits here. We can enable wide mode, tall mode by using these codes. Now we're not going to take a look at them, but they are there if you feel like messing around with them. So far all I've done is clear the screen, and I'm going to print out that text. So print out text 00, and for the color I'm going to just pick white, so I'll use color 7. So now you can see we've printed out tinycode Christmas to the screen, with the top left hand corner being where we are starting to do the printing. So I am going to move that down a bit, and I'm going to put it to 64 on the y-axis, and I'm going to leave the x-axis for now because we're going to be animating it over to the left. But what we need to do is actually animate this and draw it letter by letter. So if we print this as one thing and then we animate the print function with the text, the animation that we do is going to be applied equally to every character. They'll all move up, they'll all move down, they'll all move left, they'll all move right. What we need to do is actually visit each letter individually and print them out one by one, and apply a sign value to each letter individually, because we want that kind of a sign pattern with each one of these letters being a slightly different height. So this is a for loop that is going to use the variable I. It's going to start at 1, and it's going to, that's the hash symbol there, it's going to go up to the number of letters in this string, and you can use that same to figure out the number of items in a table. I'm just going to switch over to our characters here as well so we can take a look at how we're doing. And I now need to print individual letter. So printing text in Pico 8 is quite nice. I can just index it with the square brackets I for the value that I currently want, and it will print it out. Now I'm printing out every single letter at the same X and Y coordinates, so they're kind of all bunched up on top of each other. That's not what we want, so I'm just going to spread this out a bit so that we can see our calculations a bit better. And what I'm going to do is I'm going to take this X value, and I'm going to use I as that value. So you can see it's still a bit bunched up, so every time it's, so the first letter is printed at x equal to 1, the second is at x equal to 2, so I'm just going to multiply this by 4, which I think is the width of the characters in Pico 8, and it is. So we can now print them out letter by letter individually, and it'll just print out. So the next thing that we have to do, and it's the main thing that we're actually doing as part of this, is to modify each individual letter by a sign value. So now I'm going to use I as that value, and you can see that it does absolutely nothing. So that the sign in Pico 8 is going to return a value, but the angles, it doesn't take angles or radians, it takes turns, and they are anything that is a whole number, as I is going to be the same value, returning the same offset every time. So what I need to do is I need to divide this by 9 maybe to vary it a bit, and you can see that now the letters are starting to move a bit and take on a bit of a pattern, slight movement only by a pixel or two. And what I'm going to do is I'm just going to exaggerate that by multiplying it by 5. So the sign value comes back, and that's between +1 and -1, so that's only a pixel either way. So if I multiply it by 5, there's now the potential for it to be moved by ±5 pixels. And you can see that we now have successfully applied the sign to each individual letter. Now, part of the challenge is for you to animate it. So this is the term that you will be animating in the Y direction. to make it up and down. I'm going to just quickly add some animation in the horizontal direction here, and if I run that, I'm subtracting t. That's a bit slow, so I'm just going to multiply that maybe by 20, and you'll see that that is moving off the screen nicely there. And if I want to make this start off of the screen, I can just add 128 at the start, and now that'll push that over 128 pixels, so it starts from the right hand side of the screen and eventually comes back over to the left hand side. So with the scroller, your challenge is to animate it in the Y direction. So these are individual letters are to move up and down. The text should wrap, so when it goes off of the screen, it should go back around and come back on. It should, and you have 150 characters, which means that you should be able to combine this with another effect. And in the time-honored tradition of the Demoscene, you could maybe give some greets. Don't forget to check out the website for the full details of the challenge and the expert challenge. And don't forget to come back tomorrow for the next challenge. The video tomorrow is going to be a general video on size coding tips, and the challenge is already up today, so if you have a bit of extra time over the weekend, you can take a look at both of those challenges today.